Good morning, everyone. And I'm going to talk to you right now about the biggest single resource crisis we are facing today: access to clean water. Now, this is a problem that reaches people in Malawi, in India, in South America, but it's also a crisis that's actually much closer to home. You only have to look at California to see that it's a problem that affects both the rich and the poor. And actually, a fact, it's a billion-person problem today. The UN estimates that by 2030, half of the world's population will not have access to water. Now, this here is really the face of the problem. But whether you're a mother in Malawi trekking for 5 hours to get water, or a citizen in Flint, Michigan, affected by the contamination, or you live here in Tamil Nadu, where you're reliant on a water truck that may or may not come, and then when it does, you're paying 2.5 cents a litre. This really shows that tomorrow's challenges are at our doorsteps today. So what is the solution? I mean, the ironic thing is we live on a blue planet, but 98% of all of our water is in our seas, and only 1% is available for drinking. To be able to support population growth, we need to tap in to this huge resource. We need to desalinate, which means turning seawater into drinking water. However, currently, this process, while only producing 0.5% of all of our drinking water, is at the expense of 1% of the world's total energy. Do the math. It's not sustainable. And for a solution to be viable, to be real, it has to be sustainable. So this is our solution. So it's a patented, solar-powered, off-the-grid desalination unit that can purify water from any source. We use no filters, no membranes, no pre-treatment chemicals, and it has a lifespan of 20 years. So this is a bit of the magic behind the tech, I should say the patented magic. We take the thermal energy to heat the water, the electric energy to boil it, and then pass it through a heat exchanger to recycle the energy back into the closed system, giving us really high yields. And of course, behind every technology, every product, is a really strong team that all share the vision of Desolenator. And we're currently based at Imperial College in London. This is what it looks like practically. And actually, our co-founder, Alexi, has one of these on his roof in India. These are just a few places where we can see the tech working. Yachts is another really big one. If any of you have boats, you'll know water's a bit of a problem. And this is the really exciting bit, because it means that we can do it for everyone. So the Desolinator produces clean, safe drinking water at the cost of 1 cent per litre. So even though we do have global applications, for the first few years, we're going to be focusing on the American market, and then for other economies, we're going to do maximum order quantities, and then a lower cost unit for developing economies, and then eventually a community-sized one for humanitarian scenarios. We're finishing our investment seed round at the end of this year, and I'm actually really happy to tell you guys we're nearly fully subscribed. And then at the end of next year, we will be bringing this product to market. And I guess for us at Desolinator, this is really what it's all about. It's family by family, household by household, community by community, bringing water independence. Thank you.
In terms of technology, just to understand, it's evaporation, and how does it work?
So it's actually, it's not a revolutionary technology, it's actually an evolution of something that people have been using for hundreds of years. It's a simple process of distillation.
So if it's distillation, how do you avoid precipitation of salt and clogging of everything?
So yes, so scaling and fouling is an issue. We've got two ways that we deal with that. The first is we have quite a high throughput rate of water, so that means that there's less scaling and fouling. We've also got quite a clever way within the system, because we're creating steam. So we have I can't go into too much detail, but we have a very simple way of steam cleaning the device internally. So that way we can keep it clear of salt and other contaminants. part of it. Yeah.
One of these units, how much water does it produce, and how does that compare to the average family need?
So the unit
Per day.
that we have is 1.3 meters by 1 meter, and for that space we'll produce 15 to 20 liters a day based on 8 hours of sunshine. So it's family of 5.
Okay, sorry, just to complete my question.
Oh, sorry.
I'm sorry. Do you truck the water to the desolinator? Do you pump it? How do you get it through?
So the desolinator is dependent on you having a water source. So you can actually attach a pump, and the pump can be solar. But you can use water from the sea, from a contaminated borehole, from a river, from a lake, from a puddle, if you want. But you need a source, yeah.
How do you have quality water? Because distillated water has no minerals, and you cannot drink that. So you need minerals for the safety of the people, for the health of the people.
So you would have to remineralize the water, but we actually see this as quite a great opportunity. So for example, if we're working with NGOs or intergovernmental organizations, you can actually start looking at nutrition and remineralizing the water with something else than just simple minerals. But yes, you do have to remineralize it because it's just pure water.
What about the maintenance of your equipment?
So this system has been designed to be very easy to maintain. In the sense that we don't have any filters, we don't have any consumable parts. The only consumables we have is after 2 years, we need to replace the battery, which is a modular thing, and we have an Arduino chip in there, so we're pinging out some data for mobile payments and things like this. So it's really about cleaning the panel, and then once a week, once every couple of weeks, do an internal steam clean, which we've tried to make as easy as possible.
Okay, we're out of time, unfortunately. Thank you very much.